Alright, welcome back. This is video 5 of this section. Let's continue on with our sample problem I. We're trying to find out how many molecules are in 33 grams of ibuprofen. Well, we've already figured out that there are... Whoa, hold on. It looks like I made a bit of a mistake. And my mistake is right here. 33 divided by 206 is not 1.5, it's 0.15. So correct that if you haven't corrected that. So my mistake, sorry about that. So in 0.1599 moles of ibuprofen, write it out, don't be lazy. We want to find out how many molecules of that are there. Well, that's easy. We can use Avogadro's number, just like this. We know that for 1 mole of anything, there are, what is it? 6.022 times 10 to the 23rd molecules. And we do our math, and we come out with 9.6 times 10 to the 22nd. All right? And finally, the last part is, how much carbon is there in 33 grams of ibuprofen? Well, what we can do is we can use our formula to make a conversion factor. We know that there are 13 moles. Let's look at our formula right here. We know that there are 13 carbons in one molecule. That means that there are 13 moles of carbon in 1 mole of this molecule. We can make that a conversion factor. So I'll just do that right now. We can say 13 moles of carbon are in 1 mole of ibuprofen. Write it out. Don't be lazy. Now that we have that conversion factor, we can go ahead and use the moles we found out in part 1. 1.1599 mole. I don't have room to write it out. Guess I'm going to be lazy. Ibuprofen. And we do the math, and what do we get? We get about 25 grams of carbon. All right, that was a long example problem, but I hope it showed you a couple of interesting things. How to get moles from grams, how to go from grams to moles, how to go from number of moles to number of molecules. I'm going to get a new page, and let's continue on. On page 242, Mr. Worley, this sounds so familiar. We've done grams to moles and grams to molecules and moles to molecules before. This is easy. I'm glad you think so. Oh, check it out. Here's some good quiz questions. Do you feel comfortable doing these? If not, work them through. Okay, we're on page 242 now. Now we're going to do something just a little bit different. It's another calculation, and it's called percentage composition. Read with me. It is often useful to know the percentage by mass of a particular element in a chemical compound. For example, suppose the compound potassium chlorate, KClO3, were to be used as a source of oxygen. It would be helpful to know the percentage of oxygen in the compound. To find the mass percentage of an element in a compound, one can divide the mass of the element in a sample of the compound by the total mass of the sample. Then multiply times 100. And so it says, okay, you got the mass of the element in a sample of the compound. You divide it by the mass of the sample of the compound times 100 equals the percent element in the compound. Alright, so that's basically saying you take the oxygen out, weigh it, and divide, you got it. Please move on with me to page 243. Well, on page 243, it says, the mass percentage of an element in a compound is the same regardless of the sample size. Therefore, a simpler way to calculate the percentage of an element in the compound is to determine how many grams of the element are present in 1 mole of the compound. Well, yeah, that's easy. Instead of doing the experiment, just do a little calculation with moles. Then divide this